BPC-157 and tissue repair, healing science, or biohacking hype. Welcome back to Oxyzen Health Intelligence. In the previous episode, we introduced BPC-157 as a synthetic 15 amino acid fragment derived from a naturally occurring gastric protection protein. Today, we'll take a closer look at the specific reason this peptide has captured so much attention: tissue repair. This is the claim that turned BPC-157 from a curiosity into a viral topic among athletes, injury recovery communities, gym forums, and the wider biohacking world. Users say it helps tendons, ligaments, muscles, joints, gut tissue, and even nerves. But what does the scientific record actually support? Most of the strongest evidence so far comes from preclinical research, animal models and laboratory experiments rather than human trials. Across those studies, researchers have tested BPC-157 in a range of injury models: torn or damaged tendons, crushed or cut muscles, injured ligaments, chemically or physically injured gut tissue, vascular damage, and models of nerve damage. The recurring theme is that BPC-157 seems to modulate biological processes involved in repair. One of the most discussed mechanisms is angiogenesis, the formation of new blood vessels. Why does that matter? Healing tissues need a reliable blood supply to deliver oxygen, nutrients, immune cells, growth factors, and to clear waste products. Several studies suggest BPC-157 can influence signaling pathways tied to blood vessel growth, including interactions with vascular endothelial growth factor, VEGF signaling, and may also affect nitric oxide pathways, which regulate vessel dilation and local blood flow. Put simply, BPC-157 may create a more favorable local environment for healing by improving circulation, tweaking inflammatory signaling, and altering the balance of growth and repair signals. Tendons offer a helpful example of why this might be appealing. Compared with muscle, tendons have a sparse blood supply and a slow, often incomplete capacity to heal. In animal experiments, BPC-157 has been associated with enhanced tendon outgrowth and changes in molecular markers tied to repair, findings that help explain why athletes and trainers started to take notice. But those promising preclinical signals are not the same as proof of safe, effective therapy in humans. It's important to be cautious about how we interpret these studies. Many compounds look powerful in animal models but fail to deliver in rigorous human trials. That's why good clinical evidence, randomized controlled trials that measure objective outcomes like imaging, functional recovery, and long-term safety, is essential before we can say a treatment really works in people. Testimonials, anecdotal reports, and before and after gym pictures do not meet that bar. There are also important safety questions that deserve serious attention. Any agent that promotes angiogenesis raises a theoretical concern. Could it inadvertently support the blood vessel growth that feeds an existing tumor? That possibility has not been proven for BPC-157 in humans, but it's a scientifically sensible question. Likewise, modifying inflammation is a double-edged sword. Inflammation is an organized biological response that removes damaged tissue, clears debris, and sets the stage for regeneration. Blunting or redirecting that response at the wrong time can actually impair healing. There are also practical safety issues. Many BPC-157 products sold online are unregulated with uncertain purity, dosing, and sterility, all of which pose risks. Context matters. The right scientific question is not simply, does BPC-157 reduce inflammation? A more useful question, and the one clinicians and researchers should ask, is, does it improve the timing, quality, and durability of repair in humans without introducing unacceptable short or long-term risks? That requires careful dose finding, controlled comparisons, objective outcome measures, and extended follow-up. Finally, athletes should be aware that BPC-157 is prohibited in sport by major anti-doping bodies. Beyond legal and ethical issues, this highlights the broader point. Excitement and plausibility are not substitutes for rigorous proof. In summary, BPC-157 is scientifically interesting. It appears to interact with biological pathways important for tissue repair in preclinical models, especially processes related to blood vessel formation and local signaling, but it is not an established, proven therapy for general injury repair in humans. Until we have high-quality clinical trials, people should treat online claims skeptically, avoid unregulated products, and consult qualified health professionals before experimenting. I'm Dr. Yende. This is Oxyzen Health Intelligence. In the next episode, we'll explore the most surprising corners of BPC-157 research. Links with the gut-brain axis, effects observed in alcohol models, interactions with dopamine signaling, reports of mood changes and emotional blunting, and what those findings might mean for both hope and caution.